Today we started talking about pressure-induced form drag. Now, form drag or lift forces are created when there are pressure asymmetries, either between the front and the back, or the top and the bottom, or the lateral sides of the object. And so, if we have an arbitrary object with flow approaching it, the question is, how do we create an asymmetry in pressure where you have higher pressure on the front, lower pressure on the back, such that you create a net drag force, F sub d? Today we just focused on the mechanisms for that, and the key one for this, for the drag force, is the creation of a separation zone behind the object, where the streamlines do not follow the object, but instead come back together somewhere well behind the object. This is known as the separation zone, and it's a region of lower pressure. And the reason it has lower pressure is that the pressure has to be uniform everywhere within the separation zone, which means it has to match the pressure on these lateral edges where the velocity is higher and the pressure is lower. So that's the key factor in defining the drag force, is this creation of a wake or separation zone in which you have lower pressure, and that leads to this pressure asymmetry. Now, the other thing we talked about today was lift forces, and for lift we need to either have there's two mechanisms that we talked about: a spinning object, that would be, say, a sphere that's rotating, and if it's rotating in a counterclockwise direction, as the velocity approaches, the streamlines become sort of rerouted below the object, leading to high velocity and low pressure, and this creates a downwards lift force. If the spin is reduced, the lift force is reduced. The second is an asymmetric object, and the example that we focused on today was the airfoil. I'll revisit this a little bit on another day, but the key factor here is that, I didn't draw this very well, the stagnation points are offset from one another, and this creates a net circulation around the object such that you have lower pressure on the bottom, lower pressure on the top, higher pressure on the bottom. So the asymmetry of the orientation of the object is what creates that lift force upwards. I'll revisit that a little bit in our next lecture. I know that was a source of some confusion, but for now it's really just focusing conceptually on how these forces are created. Next lecture we'll formulate them.